Okay, let's have a look at how we could use the regression line of y on x to calculate values from once we've got the equation of the line. Okay, so here we have a table which represents the circumference of some pine trees, and for each pine tree, if the circumference is 0.75 meters, then the height of that pine tree was 8.7 meters. And we're trying to establish whether there's any correlation between the circumference of the pine tree and the height of the pine tree. So here's the table. I've drawn a scatter diagram, so it looks as though there's a positive correlation between the circumference of the tree and the height of the tree. But let's go on and work out some values. Okay, so I'm going to put these bits of data, I'm going to put this paired data into my calculator, and I'm going to generate the values that I need. Okay, so I've put all of the data into my calculator, and I'm just now going to write down the information that I've got. So I know that sigma x is equal to 3.87. I know that sigma y is equal to 43.6. I know that sigma x squared, well, that comes out as 2.5275. Sigma y squared, I don't think I actually need that, but I'll write it down anyway, is 320.96. And sigma xy is equal to 28.447. You can check this yourself on your calculator to make sure that you know what you're doing. Okay, so the first thing I need to find out is the mean of x. The mean of x then is going to be 3.87 divided by 6, because there are 6 bits of data. So the mean of x comes out as 0.645. The mean of y comes out as the sum of y, so that's 43.6 divided by 6, which is 7.26 recurring. Okay, so first thing I need to work out then is b, and I know that b is equal to sxy divided by sxx. So I need to work out both of those. Okay, so first of all, sxy then. Sxy is going to be sigma xy, well, that's the 28.447, minus sigma x, well, that's 3.87 multiplied by sigma y, 43.6, and that's divided by n, which is 6, and sxy comes out as 0.325. Comes out as 0.325. Okay, so let's go on and work out sxx. Sxx is going to be sigma x squared, well, that's 2.5275, minus sigma x squared, well, that's 3.87 squared divided by 6, and sxx comes out as 0.03135, 0.03135, which means that b, which is sxy, so b comes out as 0.325 divided by 0.03135. b then is 10.36 or thereabouts. Okay, so 10.36. I'll round it later. Okay, let's go over to here now. So we know that a, to find a is equal to the mean of y minus b times the mean of x. So the mean of y we've already established is 7.26 recurring, so the 7.26 recurring, or we could stick in the values there, minus b, so that's the 10.36, saved it in the memory of your calculator, times the mean of x, which was 0.645, and if we work that out, a comes out as 0.5800, 0.5800. So the equation of my regression line of y on x is y equals a. I'm going to write each one to 3 significant figures, 0.580 plus 10.4x. Okay, so let's say we're then asked a question, and the question says, find the height of a tree with a circumference of 0.7. Now, 0.7 is an x value, the height of the tree is a y value, we're finding y from x, so we should be using the regression line of y on x, which we are. So how could we find the height of a tree with circumference 0.7? Now, we don't actually need to draw the regression line here. We could draw the regression line by in this case, we couldn't actually do the intercept, but we could certainly find the point corresponding to the mean of x and y, and we could probably stick in a value, an x value of 1 to find the y value that goes with that and draw our regression line. But the easiest way to find values is actually just using the equation. So what we're saying here is when x is equal to 0.7, y is going to be 0.580. Now I would use the accurate versions here, plus 10.36, which you've saved in your memory, multiplied by 0.7, and if we work that out, y comes out as about 7.83 meters, which would be fine. And the reason this is fine is because this 0.7, the x value 0.7, is within the range of the available data. So we're what's called interpolating from the graph. An interpolation, which means that you are reading off a graph or using an equation, but you are looking at the range of data which is available to you and has been tried and tested. Interpolating is fine. But what if the question said to you, can you find the height of a tree which has a circumference of 1 meter? In other words, they're saying x is equal to 1. Now, if you look at what's happening here, x equals 1 is beyond, it's outside the range of the available data. So it might not necessarily be accurate. And this reading or trying to read something off a graph which is outside the range of the available data is called extrapolating. And extrapolating should be treated, let's say it's not fine. Okay, extrapolating, in other words, going outside the range of the available data is not good. So I wouldn't use the equation here to work out what the height of a tree would be if its circumference was 1 meter. We don't know what happens. It could be that pine trees fall over or something when they reach a circumference of at least 1 meter. We don't really know. The point is, we don't know. Therefore, we shouldn't really use values which are outside the range of the data.